Good morning once again and welcome to our discussion on principles of economics. In our last class, we learned how to think like an economist using the economic models, and we discussed two important models in our last session. Those were circular flow of the economy and also production possibility frontier. Production possibility frontier is an useful tool to discuss many of the economic situations. In today's session, we will be using that production possibility frontier, what we learned in our last session, to understand how trade can make everyone better off. If you recall, one of our 10 principles was trade makes everyone better off. So we also learned that in our society, instead of being self-sufficient, we specialize in a particular goods and services production in which we have expertise, and thereby we depend on others for other goods and services. So exchange happens in our society. So the society is interdependent. So that is why in today's session we are going to talk about interdependence and gains from trade. Okay, this is the principle. We have learned that trade can make everyone better off, and how nations or two individuals can actually gain from trade. That is what we are going to discuss. So we are taking a simple example. As we said that we will be using some assumptions to make the complicated word very simple. And if you recall, we said that in the context of trade, we will assume only two countries and there are two particular goods. But in reality, there would be n number of goods and n number of nations engaged in trade. We can easily extend this framework to that in country, in commodity situation also. But for these principles of economics, we will be discussing a simple case. So this learning, of course, will be helpful in other contexts as well. So there are two countries, the US and Japan, and they are producing two goods, computer and wheat. And to keep things simple, we assume that there is only one factor of production, that is labor, which is measured by labor hours. And just we will look at how much of these goods are produced in each country. If the country chooses to be self-sufficient and if it trades with other country. So two situations, both the situations. So when the country is not engaged in trade, what is the amount that each country is able to produce and consume? And next, we will also assume the context wherein US and Japan they are engaged in trade with each other, and we'll see what is their level of production and consumption with trade, and then we'll show that with trade situation is better than without trade in terms of higher level of consumption. So the production possibility frontier for the US we are talking about now. The US has 50,000 hours of labor available for production every month, 50,000 labor hours. And production of one computer requires 100 hours of labor, and production of 1 ton of wheat requires 10 hours of labor. Okay, that is the situation. Now, the US has enough labor to produce 500 computer. How will you draw the PPF? See, PPF, if you recall, we said that if nothing is mentioned otherwise, we will assume that the PPF is a downward sloping straight line, indicating the fact that it has a constant slope. That means the opportunity cost along the PPF is same. That means substitution possibility for one good for other is constant. If you recall, that is what we discussed in our previous class. Even though it may not be realistic in the real world, we will be assuming all the times the downward sloping straight line PPF. And to draw a straight line, as you know, we need intercept and the slope. Okay. So, the easiest way to draw PPF is, given the total labor hours, first we will assume if all my labor hours is devoted to computers, then how many computers a country will be able to produce. Since it is 50,000 and 100 hours of labor is required for producing one computer, when US is producing only computer, 500 computers would be produced. So, that way you are getting the x-axis intercept of this particular PPF. Next, we will assume if all the labor hours are devoted for producing wheat, then the US will be able to produce 5,000 tons of wheat. So, now you know the x-intercept, now you know the y-intercept. By simply connecting these, you will be getting the PPF. That is the easiest way to draw the PPF. Now, if you recall, we learned from our previous class how to derive the opportunity cost of the product which is measured in the x-axis. Okay. So, PPF gives opportunity cost of the good which is measured in the x-axis in terms of the good which is measured in the y-axis, and thereby the slope. Okay. So, here what is the opportunity cost of computer then? The opportunity cost of computer is basically, how will you get that? So, that means you have to, again if you recall, rise over run. Okay. So, that means if you get one extra unit of computer, so computer production is rising, how much wheat production is falling for you? So, that means to get 500 computers, you are sacrificing 5,000 units of tons of wheat. So, to get one computer, how much you are sacrificing? 5,000 divided by 500, which is basically, what is the amount? 10. So, opportunity cost of computer is 10 tons of wheat. Opportunity cost of one computer is 10 tons of wheat. That is the slope of this PPF if you take minus rise over run. Okay. Minus indicates downward sloping, rise over run. That simple phrase will help you understand the slope. Same way, please remember, if you want to measure the opportunity cost of wheat in terms of computer, it is better to measure wheat in the x-axis and computer on the y-axis. It would be just the reciprocal of the opportunity cost of computer, which will be minus 1 by 10. So, opportunity cost of wheat is 1/10 of computer. So, that is how you can get the opportunity cost of the other product when you measure that product along the y-axis, sorry, x-axis. Okay. So, now let us assume that US uses half of its labor to produce each of these goods. Okay, half of its labor to produce each of these goods. So, then how many computers will be produced? 250 computers and 2,500 tons of wheat. Very simple. Okay. So, half of my labor force I am using to produce computer, half of my labor force is used to produce wheat, and that means you are producing 2,500 tons of wheat and 250 computers. This is the point. Okay. Very simple, because 25 total labor hours was available 50,000. You divide it to equal portion 25,000, 25,000. If you devote 25,000 of your labor hour to produce a computer, then you will be able to produce 250 units of computer, because one computer requires 100 hours of labor. Similarly, If you devote 25,000 amount of hours of labor for wheat production, you will be able to produce 2,500 tons of wheat. So, this is what we know, very simple. Now, let us derive Japan's PPF, and this is the information available. Japan has 30,000 hours of labor, and producing one computer requires 125 hours of labor, and producing 1 ton of wheat requires 25 hours of labor. So, the way we learn to derive PPF for the US, same logic is applicable here. So, to draw a PPF, we must get the x-intercept and the y-intercept. How do you get x-intercept? So, when you are measuring wheat in the x-axis, computer in the x-axis, so what you have to do, entire 30,000 of your labor hour you have to devote for computer production, and in that way Japan will be able to produce 30,000 divided by 125 units of computer. In the same way, we have to also assume that Japan is devoting 30,000 hours of labor entirely for wheat production. Then how many tons of wheat Japan will be able to produce? 30,000 divided by 25. So, that is exactly the way we are drawing Japan's PPF. Okay. So, when the entire labor hours is devoted for computer production, Japan will be able to produce 240 computers. Similarly, when the entire labor force is devoted for wheat production, Japan produces 1,200 tons of wheat. How we are deriving it? Simply dividing the entire labor force by the amount of labor you need to produce 1 unit of wheat. That means 1 ton of wheat. So, this is Japan's PPF. And then again, what is the slope of this PPF? Simply rise over run. So, that means you have to divide 1,200 divided by 240. Okay, that is the slope of this PPF. All right. Now, if you look at from this discussion, what we have learned, that the US has absolute advantage in producing both the commodities, because US requires less amount of labor for producing both computer and wheat. I will go back once again. Look at here, for producing computer, Japan requires 125 hours of labor, and this value was 100 for the US. That means US requires 100 hours of labor to produce one computer. Similarly, producing 1 ton of wheat requires 10 hours of labor in the US, which is 25 hours in the context of Japan. So, that means US has absolute advantage in producing both the commodities. How is the absolute advantage defined? If a country requires less amount of input for producing any particular commodity, then we say that that particular country has an absolute advantage. In this context, since we are assuming only one factor of production, that is labor, and the US requires less labor for producing both computer and wheat, it means US has absolute advantage in producing both the commodities. That means US has expertise in producing both the commodities. Obviously, then the question comes, if US has absolute advantage in producing both the commodities, is it possible for the two countries to engage in trade? Because apparently it seems the country should specialize in an area where the country has expertise. Here is a case, the US has absolute advantage, that means expertise in both the commodities. Then why should the US engage in trade with Japan? Now, interestingly, please keep in mind, even in this case also, trade is possible. And the guiding force of trade is not only based on absolute advantage, but on another advantage which is called comparative advantage. This is very important. What does comparative advantage means? We need to calculate opportunity cost of each product for both the commodities. For example, opportunity cost of computer in terms of weight, it was how much? 100 divided by 10, or if you recall, we said that it was 10 units of computer, 10 units of 10 tons of weight per unit of computer. That was the opportunity cost of weight in terms of, sorry, opportunity cost of computer in terms of weight. We will go back once again to the US. This is the US. Okay. So, if you divide rise over run, that means 5000 divided by 500. So, it is coming out to be 10. So, opportunity cost of computer in terms of weight is 10. Now, if you calculate the opportunity cost of computer in terms of weight for Japan, what is the value? Look at this. So, you need to divide 1200 divided by 240. So, how much the value will come? So, it will come as 5. So, that means Japan has comparative advantage in producing computer, even though US has absolute advantage in producing both the commodities. Since Japan has a comparative advantage because its opportunity cost is 5, which is lower than the US. Opportunity cost of computer in terms of weight is only 5 for Japan, which is 10 for the US. Okay, that is why it is possible. Similarly, if you calculate the opportunity cost of weight in terms of computer, it was 1/10 for United States and it is 1/5 for Japan. So, that means since 1/10 is less than 1/5, we can say that the US has comparative advantage in producing wheat. So, one principle we learn from this simple exercise, you should keep in mind that it is possible for a country to have comparative advantage even though it does not have absolute advantage in both the commodities. This is the case. Japan does not have absolute advantage in none of these commodities. US has absolute advantage, but Japan has comparative advantage in computer, because comparative advantage means relative to the other product, how I am using labor. So, when I calculate the opportunity cost of computer, it is only 5 for Japan and 10 for the US. That way I am saying Japan has comparative advantage in producing computer and the US has comparative advantage in producing wheat. So, obviously, there is a possibility that these two countries can engage themselves in trade, and in that situation, which country should export which product? The country will export the product in which it has comparative advantage. So, if the US and Japan engaged in trade, Japan will export computer because it has comparative advantage in producing computer, and the US will export wheat because it has comparative advantage in wheat production. Now, is it going to be beneficial? Let us assume that to start with, both the countries are allocating half of their labor force for producing wheat and half of their labor force for producing computer, and in that way Japan, how much computer and how many tons of wheat? 120 computers and 600 tons of wheat. Okay. Let us now assume that the US goes to Japan and giving an offer. The offer is like this. US is saying to Japan that since you have comparative advantage in producing computer, why don't you devote all your labor force to produce only computer? And US is producing, let's say, 3,400 tons of wheat and 160 units of computer. And then US is asking Japan that you give me 110 units of computer, in return I will give you 700 tons of wheat. Okay. So, 110 units of computer is traded with 700 tons of wheat. My first question is, should Japan accept this offer or not? Can you think of? If yes, why? If not, why? So, the US is offering this 700 tons of wheat the US will give to Japan if Japan gives 110 units of computer. How will you decide? So, the decision principle should be like this. Japan should accept this offer if it feels that it is getting a better, if it is better to import wheat from the US instead of producing it here. How will you determine what is the opportunity cost of computer in terms of wheat? So, the Japan has to sacrifice 5 units of wheat to produce one computer. And here, when the US is giving 700 tons of wheat for 110 units of computer, that means what is the opportunity cost coming? If you divide 700 divided by 110, so that is coming out to be 6 point something. Okay. So, that means I am getting actually more wheat when I am importing from the US rather than producing within my country. If I stop producing one computer and go for wheat production, how much tons of wheat Japan will produce? Only 5 tons. Okay. By sacrificing one computer, Japan will get 5 tons of wheat. Okay. But when it is trading with the US, it is getting 6.4 tons of wheat by sacrificing one computer. So, obviously, it is a better deal for Japan. That is why Japan can actually accept the deal, because the opportunity cost value of producing computer is much higher in its own country. If it sacrifices one computer, it will get only 5 tons of wheat, but when it is trading with the US, it is getting more than that. Okay, it is more than that. Now, see what is happening. So, without trade, US consumers get 250 computers and 250 tons of wheat. Japanese customers get 220 computers and 600 wheat. Now, what will happen with trade? So, this is the offer. Suppose the US produces 3,400 tons of wheat, and then how many computers would the US be able to produce with the remaining labor? And draw the point representing the combination of computers and wheat. It is very simple. So, when 3,400 tons of wheat is produced, that means that requires how many hours of labor? So, 1 ton of wheat requires 10 labor hours. So, 3,400 means 34,000 labor hour is required to produce wheat. Alright. And what is the remaining labor hours? 16,000. And with 16,000, how many computers the US would be able to produce? 16,000 divided by 100, which is 160. So, that means x axis intercept is 160 and y axis intercept is 3,400. That is how you can draw the PPF in this context. Similarly, suppose Japan produces 240 computers. How many labor hours it is required? 240 multiplied by 125, which is exactly the entire amount of labor force, which is 30,000. So, that means, sorry, the 240 multiplied by, look at here, this is the US PPF. As I told, 16,000 labor hours remaining for computer production, and thereby you are able to produce 160 computer and you are producing remaining 3,400 tons of wheat. And this is Japan's PPF. 240 computers require all of Japan's 30,000 of labor hour. Okay. So, Japan would produce 0 tons of wheat, right. So, if all the labor hour is spent for wheat production, sorry, computer production, Japan requires 240 multiplied by 125, which is 30,000. So, US is asking Japan to concentrate only on computer production. That is why Japan is now producing 240 computers. Now, Japan has to give 110 computers to the US. And in return, it will get 700 tons of wheat. So, then how many computers will Japan get after this trade? 240 minus 110 is 130. And earlier, when Japan was producing allocating half of its labor force for producing computer and half for producing wheat, how many computers Japan was producing? 120 only. Now, Japan is getting 130 units of computer, and in return it is getting 700 wheat. And how many tons of wheat Japan was getting? Only 600 earlier. So, look at this case. This we have explored already, that you should export the commodities in which you have comparative advantage. That means you are selling abroad, and goods produced abroad are sold domestically by imports. Now, look at this. This is the offer. 700 tons of wheat for 110 computers for Japan.